Alright, welcome to another video. So today we're going to be talking about surfactant and could we use that for coronavirus or COVID? Let's find out more. So if you're new to this channel, welcome. I'm Dr. Ford. I'm a pediatrician and a neonatologist. And in this channel, we basically talk all about babies, from premature babies all the way to 1-year-olds, from a medical standpoint and also from a parent. So if this is something interesting to you, then go ahead and hit subscribe. And if you like the videos, please like them. Go ahead and hit that notification button. That way you'll know as soon as I post something. All right, let's get on with today's video. So as a neonatologist and a researcher in pulmonary medicine, I wanted to see if there was any connection between surfactant and coronavirus infection or COVID. So today we're going to be looking at the actual structure of coronavirus. We're going to look at the biochemical and the biophysical properties of surfactant. Then we're going to see, is there any evidence that coronavirus infection in the lungs could look similar to premature lungs? And then finally, we're going to be looking to see if surfactant could be used as a medication to help ameliorate the symptoms of pulmonary disease in coronavirus or COVID infection. We're going to look at the benefits and the risks of the possibility of giving surfactant for these patients. With that, let's go into detail on each topic. Okay, let's look briefly at the structure of coronavirus. So coronavirus is an RNA single-stranded virus. What that is ribonucleic acid, and it's single-stranded, meaning there's only one strand. And this is different from the typical DNA we're all used to hearing, which is DEOXYRIBONUCLEIC acid. And that one is double-stranded. There's two sides, and they kind of form this helical complex that you've seen on TV and you've studied if you've studied it in school. So this single-stranded RNA is actually surrounded or encapsulated by a membrane that's spherical in shape. And there are these spikes or S proteins that come out and radiate around this spherical structure. And it gives it a look of a crown, therefore the name corona. So how does coronavirus actually enter the cell? Well, it does so by using this S protein or spikes. This S protein actually attaches to a molecule called ACE2 or angiotensin converting enzyme 2. And this protein is actually found in different cell types of the organisms. But one of those are pneumocytes. And pneumocytes are basically your lung cells, specifically type 2. And this is where surfactant is made. Now what's also interesting is that the tip of the S protein is hydrophobic, meaning hydro, water, phobic, fear. It does not like an environment of water. So it needs to attach into the ACE2 where the other end is also hydrophobic. And what's interesting is that surfactant also has a hydrophobic side. So let's talk about that. So surfactant actually has two sides. And from a physical property, there is a hydrophobic and a hydrophilic. The hydrophilic side is hydro, water, philic, love, loves the environment of water, as opposed to the hydrophobic we talked about, which does not like the environment of water. Now, within surfactant, there are surfactant proteins. Surfactant protein A, B, C, and D. Protein A and D are hydrophilic. They love water. Protein B and C are hydrophobic. Now, protein B and C are the ones that are involved in the actual structure that help basically to open up the lungs and helps with the actual collapse of the lungs. Surfactant protein A and D are what are called defensins. They're part of a family called collectins, and they really kind of help with the immune part of the organism, as opposed to the actual structural part that's condoned by B and C surfactant proteins. Now, if we look at the biological function of surfactant, Surfactant is produced by type 2 pneumocytes, or type 2 lung cells. They're basically cuboidal as opposed to the type 1 flat cells that for the most part form the structure of alveoli, the air sacs. Type 2 pneumocytes are the ones that actually produce this substance called surfactant. So as a neonatologist, we see a lot of premature babies that are either lacking or have very small amounts of surfactant. And the lung disease that they present with is something called respiratory distress syndrome. It used to be decades ago, it used to be called hyaline membrane disease because pathologically biopsies or unfortunately autopsies, when you would actually see the lung tissue, you would see this deposition of firing called hyaline membrane. In autopsies or biopsies shown from adults who had COVID or coronavirus infection, they actually had the same type of hyaline membrane that we see in premature babies. They also had something called alveolar interstitial disease. And again, this is a disease where there is debris, there is fibrin deposition into the alveolus and into the spaces between the alveolus, the air sacs. Quite similar to what we see in premature babies. So this could lead to the hypothesis that obviously we know, and it's been studied for decades, that in premature babies that are lacking surfactant or have small amounts, when you give surfactant exogenously from outside, the babies actually do improve. Their oxygen levels drop, they do much better, and obviously survival has greatly improved. So could it be that given surfactant could also help some of the adults who present with coronavirus infection or COVID-19 infection? So the lung disease that the adults seem to present with coronavirus infection is more akin to something called acute respiratory distress syndrome, that's ARDS, as opposed to the respiratory distress syndrome that we see in premature babies. Now, there are actually older children that present to the intensive care unit with these type of pneumonias that are called acute respiratory distress syndrome. So these small studies have shown that given this surfactant in children who have ARDS, ARDS, actually does decrease their oxygen need as well as decreasing their mortality. There are other studies that have been done using surfactant in ARDS in older kids and the adults that really didn't show any benefit, and so the benefit really didn't outweigh the risk of giving surfactant, so it's not widely used. It's definitely not standard of practice, so that is important to know. There's also risk to giving surfactant, so this is why we're going to be talking about the possibilities and the benefits and the risks of giving surfactant with the next section. So this last part is more of a hypothesis or my opinion. Could there be some patients that are intubated, adult or older children or babies, that you could give surfactant as a way to be able to block that virus from getting into the organism, or also as a way to relieve if there's been some damage to the type 2 pneumocytes, that you can relieve some of the decrease in surfactant production or any damage that may have happened within the lungs, similar to what we see with premature babies. I don't know if this would actually have any effect in the older population, but I wonder if we see similar picture with the smaller babies and if given surfactant would be able to relieve them. You know, luckily, the smaller babies really have very mild symptoms and they don't seem to be presenting with anything, at least as far as we know. We don't know what coronavirus is going to do with a second wave. Are babies going to be affected? And if so, could we be able to go ahead and do some studies with surfactant in the smaller baby population to determine if they have something similar to premature baby lung disease with that hyaline membrane disease that we see as neonatologists, where surfactant actually could have a role to be able to benefit this. Again, this is not standard, this is my opinion, and I think obviously if we start seeing more cases popping up in smaller babies that are causing more disease, then we really need to look into doing a study to be able to use surfactant in these babies. So I promised I would give you a bonus if you stuck around, so I appreciate it. So here you go. Now, we've talked about the coronavirus infecting or entering through the pneumocyte type 2 cells, so the lung cells. But actually that ACE2 is also found in other cells, especially the gastrointestinal tract. It can enter through the esophagus, through the intestine, or the colon. Now, there is a way to give surfactant that doesn't go straight into the lung. There is the salsa method. I have a video on that I'm going to go ahead and add a link into the comment section so you guys can click on that, or at the end of the video you can click on that or subscribe, go to my page, and you can actually see the salsa video. And that way you actually give surfactant, and part of that surfactant actually goes into the gastrointestinal tract. So there may be some improvement or even decrease in entry of the coronavirus as it's blocking, we already talked about that, as it's blocking its way now to other cells in the gastrointestinal tract. So another way to be able to give surfactant is through an aerosolized form. So this also enters through the GI tract and may have the same blocking factor that we talked about already. So these are two methods that could potentially not only decrease the symptoms, the respiratory symptoms that we see in babies and adults, but actually could help some of the GI symptoms as well. Again, these are all hypotheses and they would need to be tested. So maybe someone out there can go ahead and do it. Maybe I'll get on it as a researcher and we'll see what happens. But again, the main thing is luckily none of the babies seem to have any major symptoms. And so, we hopefully it stays that way and coronavirus does not begin to shift into the younger population. All right. Well, thank you so much for watching. I really appreciate it. Again, if you like these type of topics, go ahead and subscribe. I have some fun videos for families. I also have some medical educational videos. And if you like this video, please go ahead and hit that notification button. That way, as soon as I post something, you'll get to see it. If you have any questions on the topics we talked about today, please go ahead and add those questions to the comments. Also, if you've used surfactant in any of these patients with coronavirus or SARS, maybe with the last epidemic that we had, or anything that you've seen regarding surfactant or have any questions, please go ahead and add it to the comment section. I'd be really interested to find out if anybody is studying this or even using it in their unit. So thanks again for watching. We'll see you with the next video. Okay, hasta luego.